I'm going to demonstrate the construction of Euclid's proposition 1 on the HP prime calculator. I'm going to use the geometry application for this, so let me open that up first. So proposition 1 is about the following. Given a line AB, finite line, we want to construct a triangle which has line AB as one of its sides and which is equilateral. That means all the sides have the same length. So let's start out by actually defining our line AB. So I'm going to pick 2 points. First point I'm going to put just here. All right, point A. And the second point, let's put it here. Oops, point B. All right. So let me next put a line segment between those 2 points. Line segment. And as you can see, I can move this cursor around, and if I move it close to one of the existing points, the point turns red, which means that it's selected like this. So I confirm the first point of the line segment and select the second point and confirm by pressing enter. And this gives us our line C. All right. Next, according to the proposition, we have to construct 2 circles. The first circle has A as its center point. So let's construct that. Commands curve circle. And again, I select A. This is going to be the center, and I want the point. And as the second point, which is on the circle, I select point B. Just like that. All right. So we have a nice circle. So now we have to construct a second circle, this time with point B at the center and going through point A. So let me put that circle here, point B, and going through point A. All right. Now the next step is defining a point that intersects the circles or lies at the intersection between the circles. So as you can see, there are actually 2 such points, one up here, one down here. And the HP prime actually has 2 different point definitions, depending on whether you want all intersections or just one. In our case, we want just one intersection. So let me show you how to construct that. So we go into commands. We want an intersection point. And you can see we have intersection and intersections. I'm going to go with intersection. And now it asks me for the first object that I want to intersect with. So I'm going to select the left circle, enter. And the second object will be the right circle. All right, now because this is still ambiguous, we have to define a reference point. And I'm going to actually put that up here. So this will construct another point G. And what this means is that it will pick the intersection point that is closest to point G. And in our case, we got this point H, which is now at the intersection. So to complete our triangle construction, we now just have to add line segments. And I'm going to add the first line segment between point A and point H. A nice thing, by the way, is if you want to make sure that you've selected the right points for your construction, the HP prime always displays the current definition of what you're constructing down here. So it's saying segment GA, GH. The G just means geometry object. So that means we are constructing a segment between A and H. And I still have to confirm H. All right. And finally, a second segment from B to H, line segment, point B, oops, to, I think I did something wrong there. Let me just do that again. Segment B to H. All right. I might have constructed an additional segment there. I can actually check all the things I've constructed by going into the symbol view. And these are all the things I've constructed, and you can see here I constructed an extra segment between B and B, not very meaningful, so let me just delete that. All right, so now we have constructed our triangle, and one really nice thing about this app is that you can now interactively change the position of the points and see how the overall construction changes. So we started out with the line AB, so let's see what happens if we move, for example, the point B around. And you can see that no matter where we move point B, the constructed triangle always remains equilateral with the line AB as one of its sides. All right, I'd like to show you one last thing. So if we want to make sure that this triangle is actually equilateral, we can use a test that the HP prime provides. And we find these tests in commands, and we have to scroll down a bit, tests, and there are a couple of those. If you're unsure what any of these mean, you can select them and press the help button. And that gives you a short description of the parameters of what the command does, and also usually has an example. So let's go back here and actually apply this test. And now I have to select the 3 points of the triangle. I'm gonna select point A, point B, and point H. And we can see the result up here. You can also move that around. So right now it's saying is equilateral, GA, GB, GH is 0. 0 means it's not equilateral. So that's a bit weird. And if we move this around, you can actually see that depending on the size of the triangle, it occasionally jumps to 1, which would be the correct result, meaning it is equilateral. So why is that? So the reason for this is that the HP prime uses numeric calculations in order to perform these tests. And if you have numeric calculations, you can get rounding errors, which is what we are getting here. So to make this more robust, one thing you can do is you can go to the cast settings by pressing Shift and the cast button. Now if you go down to page 2, you can see there's this epsilon value, which is basically telling the calculator when it should consider 2 numbers the same. So if the difference is less than this epsilon, it will consider 2 numeric values as equal within the cast, which is used for the geometry app. So let me just make this value a bit larger by removing 2 zeros here. Okay, and now if I go back to plot, you can see that we now have a robust 1 as the answer to the is equilateral test. All right, that was proposition 1, Euclid's proposition 1 on the HP prime.